So looking at solving simultaneous equations through elimination. Now, before I start, to understand what simultaneous equations are, they are basically two different equations, but they're connected by the x and the y values equal the same for both of them. So let's go through an example, solving one and some steps to do that. So with this one here, I've got 3x add 2y is 23. And underneath I've got 2x minus y is 6. So to start solving this, you want to make either the x's or the y's the same through multiplication. So this is algebra manipulation. So you can make the whole equation change by multiplying everything by the same value. And you're doing that to make either the x's or the y's the same. It doesn't matter about the sign at the front, it's just the number here. So that's technically 1y at the moment. So what I'm going to do is I'm going to multiply the bottom one, all of this, times it by 2. So I make that 2y and that's going to be 2y. So if I move over here, that will then give you the top, that will then become 4x minus 2y equals 12, because you've done 2 times 2x, 2 times minus y, 2 times 6. So now you've done that, second step, and you can multiply actually both of them if you need to, but I've just multiplied one here. Second one, if the signs are the same, you're going to subtract. If the signs are different, you add. And what that means is the signs in front of whatever you've made the same. So the y's, the y's are here, they've got the same number, and you look at the signs there. So that's a positive one, that's a negative one. So positive, negative. And what that means is you add everything. So we don't need this middle one here at the moment. We add everything, so 3x and 4x, you add that to get 7x. 2y, add minus 2y, gets rid of it. That's why we're doing elimination. It's getting rid of it. And then 23 add 12 gives you 35. So we've now got 7x is 35 through adding. So now we're going to solve to find the unknown here. So that's 7x equals 35. We divide by 7. X is 5. And then once you've done that, final step is substitute in to find the other unknown. So we've got one unknown, then we're going to substitute that x equals 5 in to any of the equations. So I'm going to substitute into the top. So if I do that, then I've then got 3 times 5, because x is 5, add 2y is 23, so that means 15 add 2y is 23. And you can then see here that 2y is 8 and y is 4. So you've got your y value and your x value in your solution. And there are two solutions here because if you plot both these lines, these are the coordinates where the two lines cross. Okay, so I'm going to do 2 more examples, a bit quicker than that first one, of how to do this. So this time I've got 2x add 8y is 43 and x add 3y is 18. So this time I'm going to manipulate the second equation to make the x's the same. Okay, so you understand, make the x's the same. So I'm going to times that by 2, and that's going to become 2x add 6y equals 18. Okay, and I'm going to just rewrite that other equation on top. Sorry, not 18, equals 36, because we times it by 2. So, done that. The signs this time, we're not looking at these ones, we're looking at here. Because there's nothing, it means they're both positive, so same signs, subtract. So 2x, take away 2x is nothing. 8y minus 6y is 2y. And then 43 minus 36 is 7. So then from that, it gives us y equals 3.5. Okay, through solving. And then to find out the x, you substitute this y into one of those two equations there. So I'll do it into the second one. So that means for that equation we have x add 3 bracket 3.5. That's just signaling multiplication equals 18. So that's x add 10.5 equals 18 and gives us x a value of 7.5. So we have our y value and our x value there. Okay, and then another example here. What you're doing on this one is we're going to have to manipulate both of them. So you times the first equation and second equation by something to make them make either the x's or the y's the same. Now I'm going to go through multiplying to make the y's the same. So the top equation there, I'll multiply that all by 3. So I'm aiming at making that 6y. And the bottom equation, I'd multiply that all by 2 with the aim to make that 6y as well. So the top equation will then become 6x plus 6y equals 42. And then the bottom equation will become 10x minus 6y equals 38. And then we go from there, same process as before. So the signs are different here, so we're adding this time, different signs add. So 6 add 10, 16x. That eliminates. And this add this should give us 80. So 16x is 80. That means x must equal 5. And then now we've got that, we could substitute that x back in. So I'm going to do it quickly. 2 times 5 is 10. So 10 take away from 14 is 4. So that means y must equal to 2 for that one there. Okay. Now I've got note there so you can remember these are the key rules. Same signs, subtract, different signs, add. And 2 for you to give a go. Pause it. Then I'll go over the answers for you. All right, I'm going to do this first one here. So I'm going to do it relatively quick. So it's going to be multiplied by 3, so it becomes 6x. Add 3y equals 36. And the top one I'm just going to rewrite. 3x minus 3y equals 9. Signs are different, so I'm going to add. So that's 9x equals 45. So that means x equals 5 if you did that correctly. And then substitute it back in. I'm going to substitute it into this one here. So 2 times 5 is 10. So 10 add y equals 12. And quite easily I can see there that y equals 2. So that's that one there. And then this one here, okay, I'm going to multiply that bottom one there by 2 to make it work. So that's going to be 6x add 2y is 42. And then top one's going to stay as 4x, 2y is 34. Now, different signs, same signs here, so we're going to subtract. But if you notice, 4x take away 6x is minus 2. To make my life easier, I'm going to just do 6x minus 4x there. So that'll become 2x instead. They cancel each other. Then 42 minus 34 is 8. And that'll give me x is 4. And once I've got that, substitute it in. So 3 times 4 is 12. Add y is 21. You can see that y should be 9. Have you got that right? And that's substituting simultaneous equations with elimination.